watching the spherical cow.
Let's go back to the Big Bang Theory, okay? So imagine way back, everything is sort of crunched together, right? So there's a heavy gravity to gravitate everything together. However, why does the universe expand?
Because it has.
So the way it is that because the space and time they're crunched together, right? And the space needs to be flat. Does it make sense?
What if you go to a dimension where there's no time?
And you'll just freeze there.
Okay, that's outside of a question. Anyway, so
Wait, is it a question? Is it valid?
yes, that's where heaven is. Okay,
You'll just freeze
and you'll
there.
have to find out later because I can't answer the question. So if you look at this, right? Let's say universe is something like this, folded up into itself, right?
Bloom.
And then it's gonna expand, boom, like that, right? What does that mean?
Oh,
Just way faster.
Huh?
Just way faster.
Which way is way faster?
The universe.
The universe is way faster? Okay. So basically the space-time needs to be flattened out, right? So it has a springiness of the space-time. That's actually what drives the expansion of the universe. Does it make sense? It's like this thing has a springiness on the frame. The universe doesn't have a frame, but the space-time itself. Let's say this material is made of sort of a rubber band sort of material, right? If you want to crunch it up, it's going to spread itself out, right? So that's what dark energy is. It
First of all-
spreads the universe back into flatness. Does that make sense?
So that's your big idea.
Yes. And you can
Why are
understand it.
you the person?
Okay,
telling
that's
me that?
not.
That's so simple.
That is simple, but sometimes things are not complicated. They're trying to find out what it is, right?
Yeah, I believe that, but it's just that.
Yeah. Another thing with dark matter. You know what dark matter is?
Yeah.
What does it do?
95% of the universe.
Yeah, because the visible matter is like matter that that has gravity, right?
Okay, now it makes sense because when you're expanding, it's like what's on the outside.
Wait, now I
And
have.
is it even physical?
It's sort of physical plus metaphysical. But we don't have you. Well, you have to think about it to understand it more fully. But right here, you heard it first. Okay. This is the way. Well, maybe some other people understand it, but I don't think anybody has articulated it like that, right? Basically, the space-time needs to be flat. So basically, when the universe expands, right? It's actually think of this point touching, right? This is tangential point. This is called tangential. This is touching, right? So that point is actually trying to expand, so it's flatter and flatter and flatter, right? To become more like the plane, right? But once can it ever reach the plane, the flatness?
No.
No, right?
It's only touching in one tiny.
For it to reach that flat plane, it becomes infinitely large, right? But we discussed the problem with infinity is what? If you have something, can something finite to suddenly become infinite? There's a basically what we learned from what we see. There's nothing that can indicate that if something is finite, it can become infinite. We're going to play back to the question.
Back to the question.
Say it again.
Back to the question.
Which question?
What's
the question?
dark matter?
Yeah, dark matter and dark energy, right? Dark energy is the mystery expansion of the universe. Something is driving it. It's actually expanding faster and faster. Think about it. If the space-time has a springiness to it, then it's going to try to flatten out, right? That's what dark energy is. We just have to measure it correctly and enough to sort of quantify it. And people wouldn't want to build another sort of theory outside of it.
Oh, how long have you known this for?
I've just come to realization what it is. Recent, okay?
Why hasn't Einstein?
Einstein doesn't have enough information when he died. So what is gravity?
Oh, something that makes us
Stick to the earth, right? So gravity.
Gravity is more of a thing that attracts things of mass to attract to the center of mass of a bigger object.
Yes, last time we discovered gravity, right? We discussed gravity. But also what Einstein found out is that what people found out is that gravity does not only work on massive stuff. Even if you're light, you don't have a mass, right? Gravity still works on it. That's why we have black holes. Because light is not fast enough to escape it. The gravity is so strong.
Really?
Yes, that's what black hole means, right? So it's black because what? The gravity is so strong. Light cannot escape it. Okay? Give it
Because it's so
light as fast as light, you can't really escape it. That's what a black hole is.
Because it's so massive?
Yes. So Einstein says, okay, if we have a big mass over there, what happens is that it bends the space-time. So sort of like dropping, if you have something flat, right? Can you hold that?
Yeah.
And then if you drop the earth on it, what happens?
It's gonna
Bends
roll
down.
it.
Yeah, it bends down a little bit right there, right? That's what happens. That's what gravity is.
Oh, I hate
That makes
that
sense?
sound.
Okay, I'll make that sound there. Let's do an orange, so it doesn't make that sound. Okay. So that because there's an orange right there. Do you have a cutie? Okay. So this is not flexible enough, but say give me one cutie. The cutie looks like a moon, right? So because of this, right, the cutie is gonna roll.
2 moons.
Pay attention. If you have 2 moons, we're not Earth. We're Jupiter, or like Mars.
No, Jupiter has 60 something.
Yeah. So let's say we're Earth, right? It bends it, right? Remember when we went to the mall? You know, you throw a coin in there.
Oh yeah.
Right?
Yeah.
It runs around, right?
I always catch.
Yeah, right. Runs around because why is that? Why is that? Because there's a curvature in space-time, right? The moon doesn't know it's going in circles. The moon just follows the space-time.
Yeah.
Okay?
Trajectory.
Yeah. Does it make sense now?
No.
That's what general relativity is. That's Einstein's explanation of what gravity is. So gravity, however massive you are, you make a dent.
It causes speed.
No, it causes the space-time to bend into warp, basically. So when you're supposed to, so the light shines through, right, like that. It's just gonna run through, right, if a light particle, right. But you have a dent right there. The light particle is gonna bend a little bit when you drive through.
Oh
right?
yeah. So there's like a surface.
So if you bend it enough, like the sun, then the light should be going this way, and then this light will go around and go that way. So you're gonna see the stars behind the sun at a different location, as if it was coming this way, right? The light is going this way, and then you have to bend this way, right? So the object should be there, you're observing from there. Suddenly it looks like it's coming from here. Actually, somebody proved that. Somebody did an observation during the solar eclipse, and then he showed that.
It's like when you're standing here. I keep an eye here, right? And I move, and it looks like you're over there now.
Yeah, different angle.
Yeah.
Different angle. Okay, all that is caused by the gravity. And then now we observe that
That's how we know we're in a 3D world.
we're in a 3D world. It's just that everything, the 3D can be projected into a 2D, can be projected to a 2D hologram.
This is your mini universe.
You know what a hologram is?
Yeah.
It's like a 3D
Like-
movie, right? 3D movie, when you wear different eyeglasses on different eyes,
Usually when
then you can construct a 3D, but then it's still a 2D image.
usually when I see a hologram, there's like a little, like really fast moving stand that like moves, so you can't see it, and then it projects light onto it.
So now, let's talk about dark matter. So what people found out is that not only the sun has, big matter, dark matter has more mass, right, than the sun. So what happened is that the Hubble telescope looked around, right, gazed into something, and they found out that what I just said, some distant galaxies were bent. They were supposed to be there.
They're warped.
And then they're warped. They look as if they're coming from here, right? What we call that gravitational lensing. It's like a lens bending the light. Okay.
It's like those things where you hold it and then you look
So
around.
that's how we observe dark matter. However, dark matter doesn't interact any other way
Wait,
with anything else.
Why did they name dark matter even though nobody knows what that is?
it's dark.
That's dark.
But it's not even matter though.
It's not matter. It's not. So I'm going to give you an explanation of dark matter.
First
Okay.
of all, your explanation did not help me in any way to not understand anything.
Wait, but if there's no dark matter, but
There is dark matter. This is very important because I'm going to show you. The dark matter is on this thing, right? Remember, this is our universe expanding, right?
Hold on.
Huh?
What if our universe is like this?
Well, doesn't matter because we're in it. It's like doesn't matter what way Earth is, right? You think North is up, but in reality, North can be down or sideways, right? It doesn't matter because we're in it,
because
right?
if you're up and
No, because if we're on the surface, it depends on
Okay.
the area of
Okay.
the sun and everything.
Which side do you like? The dark side or the bright side?
Dark side.
Dark side. It looks more like the universe, right?
Yeah.
It's kind of dark. So, like I
Can I
said,
paint
right?
it like the universe?
You can paint whatever you want after. Okay. Let's talk about this. The bending of space-time. Do you understand that? But who says the space-time has to be flat to begin with?
It can be warped.
It can be warped and creased. It can be folded. Look at it. Dark matter in our universe. When the universe expands, it doesn't guarantee anybody, hey, our space-time is perfectly flat everywhere. The dark matter is just the creases.
You can't guarantee it.
You can't, but this is what it is. From Wall's observation, it is what it is.
It is what it is. Maybe if you moved like to another area of the universe, probably the time would be different there.
For example, right now there's some creases right here, right? If we go onto the latest studies of mapping the universe, they found out that it's just like that. We have filaments in the universe that are dark matters, and then around those dark matter filaments, that's where the galaxies, all matters collect. So, for example, if we have all these You know, if you have a bunch of visible matter, listen, let me finish, please. If you have a bunch of visible matter, like little dust balls right here, and then given enough time, they're going to fall into the creases, right?
Yeah.
Right? That's how the universe gathers things into galaxies and clusters and superclusters.
But I just don't get that you're gonna like define dark matter with a physical.
That's not, well, that's what people are struggling with. The people are trying to
Also,
detect them, trying to explain them with what they know, right? The thing is that dark matter is not what we know already. Dark matter is something completely different. But the best way to explain it is that it just naturally happens to creases in the space-time of the universe.
Okay.
Does that make sense?
Creases.
You don't have to agree with me. Do
I
you
know.
understand that?
Yeah. Yes. But
You understand my point?
I have a question. Your representation is a flat surface with creases in it. What happens if it's more of this kind of situation?
Or it is. It is actually a different kind of situation.
So
This is a simplified representation. This is a 2D representation of 4D space-time. Okay? But I'm just saying that when the universe unfolds itself, right?
Also,
It does not guarantee that on the microscopic level, it is what? It is perfectly flat.
It's not.
People just assume that it is. That's why they're puzzled by dark matter.
Oh yeah.
Right? It makes sense now?
But when I say the universe, I always
Because-
think there's universe going up too, and down, and sideways.
It does. It does. Because we cannot represent that on a video. This is our best analogy of a universe for now.
I mean, this is pretty good too. They can't see us.
Okay.
You're too short.
And think about all the dust. Compared to the creases right here, they're powerless, right?
Yeah.
So that's why this is 85% I think, of the universe. And then the rest of the thing make up like
Because it falls
95%.
into it.
Yeah.
So how do people know that was 95% of the universe?
Because of the strength of the galaxy pulling everything together.
How do people know dark matter is there?
Well, like I said, there's a gravitational lensing situation from the deep gaze. And then another thing is that all the galaxy, people look at galaxy, they're spinning, right?
Is there dark matter in this room?
Unlikely that we can detect it. It expands in the space, right? For example, right here, we're very, very tiny. We're like a little virus on this thing, right?
No, we're even smaller.
Even smaller.
Atom.
That's it. We're just like a
We're cell.
cell is smaller than virus. Well, virus is smaller than cell. So that's what virus gets into a cell and it reproduces itself, right? But that's another video. So what happens is that if you're on a microscopic level, right, you feel everything should be flat,
Yeah.
right? But you don't understand you're on the creases and valleys and all
They're
that.
like mountains.
Yeah. You don't understand that because you're on a flat. It's like, think about ants, right? You know flat earthers?
Yeah.
They're mental midgets like ants, right? Because they say everything's flat, right? So they cannot imagine bigger. If you can't imagine bigger, this is what it is. We just can't see it. Because it's in the fourth dimension. We're not really visualizing it.
My question to flat earthers is, if you think the earth is flat, then why are there mountains and terrains and waves and the moon?
That's not what they mean.
And
They
the
think
sun.
on a large scale it's not a sphere. That's what they think. But everything
What's
is a
on the
sphere.
bottom then? How do you fall off? Have you ever tried falling off?
Okay, never mind. Okay, so now think about it. What are the two main revelations today?
What is dark matter?
And what is dark energy? Okay?
But
And
what is-
not even scientists, no scientists today have really articulated. People sort of understand it, gravitate to get toward it.
People dedicate their lives towards this, and you just thought about it. You're like, oh, bingo.
That's what happened to Einstein. People dedicated their lives, top scientists at the time, 100 years ago, 120 years ago. They were thinking, what's going on?
At least Einstein was a mad scientist. Like, at least he was like doing calculations on his chalkboard.
No, he wasn't.
You're like,
No, this is exactly what Einstein did. He sat there and did mental experiments. You can read
but
about,
those are all theoretical.
but he actually proved right.
You have to prove.
No, he wasn't proved right away. It was proved right after like many years.
But you have to prove yourself.
Sir Edinger of England actually went to capture the solar eclipse to take the picture of the star that has mislocated itself because of the gravitational lensing to prove Einstein right. Many years after. Not many years, but quite a few years after.
What if somebody already discovered this but never told anybody?
No, this is just a way to interpret, right? It's not a scientific theory.
It's not true.
It's true. It's just not. Just not very useful. What we can do is we can expand on these thinkings and then try to make use out of it.
But you can't just say it's the truth. You have no math backing it.
No, all the things that's shown right now. This is what it is. This is the only way to explain it.
This is a sun blocker. And also a
It's a reflector, and it's
reflector.
yeah.
It's like a eureka moment, but not.
You're the second and the third. Are you the third?
I'm
Are
gonna
you
say
the
my
second?
nose, but like.
You want to be the second or the third?
How about we do a pop quiz?
Second the best, me.
Okay. She's the third then. Because she doesn't believe it. She's skeptic.
She's a nerd. I understand it, but I don't really think.
Well, I know. I'm not saying I'm right. Nobody's right.
It's not sound.
Is this sound? There's no current knowledge fits in all our current knowledge. All I have said here fits all the known knowledge of the scientific community.
It does make sense.
Yeah. The only thing that I only pointed out their wrong assumption. Okay? Their assumption is that space-time doesn't want to be flat. I'm saying space-time looks like it wants to be flat. It has a springiness in it. That's why they call it dark energy.
Why does space-time want to be flat?
Because they're curled. They're curled up. Right? Like that. They're like,
Yeah, but like.
I'm just saying that there is a. It looks like
no,
it.
like when does space-time become like warped?
At the beginning of time. 13 something billion years ago.
So not like right now.
It is still warped. That's why it's expanding. It's not warped. It's not warped in the three-dimensional sense. It's warped in the four-dimensional sense. On the three-dimensional sense, if I look at just around, it's a flat, right? The Earth looks flat Earth.
Wait,
But if you're outside of the Earth, you know that it's warped. All right? That's the same thing I'm saying. If you're outside of time, if you think outside of time, then you know it's warped.
Okay.
And then
So
it wants to
for example-
expand. The only way. So if you look at it, there's a curvature to it, right? Look at it. It's curvature, right? Who has a higher curvature? This orange or this globe? This one. No, this one has a higher curvature. Why? Because it's smaller. The smaller things have a higher curvature. Where's that little cutie? Cutie has an even higher curvature right there,
Cherry.
right? The cherry has a higher curvature, even higher. If it's the smaller it is, the higher the curvature is. The bigger it is, the flatter it is.
Oh yeah, that's why
Right?
people there's flat earthers.
Yes.
Because you're too small.
Yes.
And when you walk, it's like.
So the universe, the space-time wants to be flat, so it expands into flatness. But,
So, wait.
but it's not infinite. What's the point it reaches perfectly flat? It's when it's what? Infinitely large.
Yeah.
Okay? Because everything is infinite. It's not sphere anymore.
But it's expanding infinitely.
Yeah.
So.
Yes, expanding. It's like expanding. And it looks
There's
like
no
faster and
end.
faster.
There's
There's
no
no end
end.
to it. So there's no end to time. The only thing is that everything on the surface, if it's a balloon, everything on the surface goes farther and farther apart from one another. That's what happens with dark energy. Dark matter, again, once it unfolds,
Oh my god.
oops, once it unfolds, microscopically, well, not microscopic for us, it's still macroscopic, really, really big for us. But for the universe itself, right? The entire universe, each
Technically,
piece
we
is
become
very small.
smaller. Technically, we become even smaller.
Insignificant, not, can't even be seen on the map right here. If this is a
We
chunk of
almost
the
don't
universe.
exist.
Yes. So the universe doesn't really care what we do, but somehow we understand what it is. Right?
Man, little mites are tiny.
But in the universe, how small are atoms?
Very, very small. But then there's a number you can compare the size of the universe and the size of the atom.
Electrons are even tinier.
0.0000000.
Are electrons physical
Point,
things?
point.
They are, they're not, depends on how you look at it. So all the physical things that you understand down to a certain scale, into quantum realm, they're different now. It's not like a particle man.
Wait.
It's not like that.
Okay, question then.
Huh?
What happens if you move to a different point of the universe? Are you in a different time? Does time move slower? Do you move slower?
Yes.
And is there a different gravity
Yes.
that proves that dark matter can exist like that?
Yes.
So
Yeah, but
hypothetically,
these are actually known facts.
exactly.
Yeah. So Einstein was so right. The only thing they sort of forgot is that space-time or the universe doesn't really care to be flat on a local scale of the universe, of the galaxy and clusters.
It can't be universally the same.
It's roughly the same. Wherever we look, it's all roughly the
If you
same.
move to a different part, right?
There's not this.
Maybe this part was developed earlier than where you are.
You don't know that. If you move to that part,
Uh,
it's much later in time.
Yeah.
Earlier in time is a different space. So whatever we see from out there, the farther we see, the older they are, right? Because even light speed is finite.
Ladies
Okay.
and gentlemen, it's official. Your life is a lie.
Yeah, that's another topic. Our lives can be simulations, like the Matrix.
Yeah.
I never watched.
And the whole universe can
I've
be the
always
Matrix.
had this weird thought.
Can you not fit it?
like I'm talking to you right now, right? I'm talking to you. You might not even exist.
I know.
I might be the only person
You purely
alive.
non-existent.
I might be the only person alive. I'm the
I know.
only person that I
I'm
know.
not touching her.
Like that's actually
Okay.
real.
Oh yeah, me too.
Yeah.
Yeah,
You're
I
only
was
the
thinking
person
about
us.
that. I was thinking about that.
Wow, what a smart boy and a smart girl. Thinking about these things so young already.
You can be. I thought it was really early. Like,
It's all a program trying to manipulate you.
what if it's just me?
Why is he forcing me to practice piano?
Yeah.
He's evil because he's a simulated program trying to manipulate me into doing things I don't want and giving me misery. Let's explain what a cone is, right? Where's the cone?
Okay.
What's
To
the
the
cone?
middle. To the middle.
Okay. That's a cone, right? So basically, the cone means what? We can only look back in time. Does it make sense? Let's say if this is our universe, oops, right? We exist at this point, and then all we can look out there is looking back into the what? Into time, right?
Yeah.
Does it make sense?
Wait, I have a question.
Yes.
Can you look into the future?
No,
Unless you're some kind of voodoo magic woman.
right? So what happens is that there's this. We're limited by this line cone, what we call it. That's our observable universe. So what is an observable universe is that whatever we can see, and then it's limited by the light speed, right? So it sort of takes on the cone shape in the 4D space. But to us, this cone is all that we know. You see the 3D space out there, right? But actually, this big sphere is the 4D sphere, right? That we know of. So imagine that this cone, see this circle at the bottom of the cone? That's the 2D projection, right? So every 2D layer of this is a slice of time,
Okay.
okay? And it has a 3D world, complete 3D world in that 2D slice.
It's like-
It's sort of like a television.
It's like when you print it out. Each slice of that.
Yes, yes, and it's continuous. So this is like a 2D, like 3D television, right? Throughout time, it actually acts out. But basically, there's certain parts of the universe that happen right here, right? that happen inside our cone, then we can detect it. If it happen outside of the cone, we cannot detect it until later on, when everything expands, when the cone expands as well along the universe, and then the light goes in. And then there are certain parts of the universe we just cannot observe ever, okay? But chances are they look pretty much like what we have here, right? This is like not a unique part of the universe that we're in. It could be, but we don't know.
What if the universe has already expanded, but we're just like a hologram of what already happened?
That's a good thought. So time is, for example, we're just 11. Time is already set.
Yeah.
We're just moving through it.
Yeah, we're just moving through it.
We don't really have a free will.
Yeah.
That's a very, very deep thought and very good question.
For example, like,
That's our next episode of Spherical Cow.
okay, nice transition. Hello. Hello.
Hold it down. Okay, pause the video.
I am the brightest person on planet Earth. La la la.
Right, let me dial up. ISO. Make you the brightest person. Look how bright you are. Brightest person, right?
Wait, turn this around.
A couple of really bright kids.
Not so bright, kid.
What did it say?
Can you read what dark matter is to me?
Here's what I found.
Hey Siri, what is dark matter?
Here's
Siri,
what I
What is
found.
dark matter?
Here's what I found.
Wait. Hey Siri, what is dark
Here is
matter?
what I found.
I have a interesting spherical cow
Hey Siri, where is dark
intro.
matter?
Ethan's like, hey Siri, repeat after me. She's like, okay.
Can I see you?
This is a spherical cow. And she's like, this is a spherical cow. And he's like, hee.
Hey Siri, repeat after me.
Because it's some sort of pledge. My end user license agreement will visit.
Okay, it won't repeat after you.